Hello everyone, my name is Rajnandini Wagmode. Today we are going to explore a very important topic in a machine learning, that is principal component analysis or PCA. PCA is a statistical technique used to reduce the dimensionality of a large datasets while retaining most of the original information. Next, objective. Our objective is twofold. First is we want to understand and implement PCA using a dataset that we will generate ourselves. Second, we want to visualize how features in a dataset relate to one another and how PCA helps in identifying key patterns and principal components. This is not just a theory, we will see the code and plots to make sense of it. Next, generate dataset. We start by generating a synthetic dataset with four features x1, x2, x3, and x4. To make it interesting, we define x3 and x4 as a linear combinations of a x1 and x2 and add a bit of a random noise to them. Why do this? Because now we have built-in correlation between features, which is exactly what PCA is a good at a detecting. This synthetic setup gives us complete control to understand what PCA is a really doing under the hood. Next, mean centering. Before we apply PCA, there is a very important pre-processing step called as a mean centering. We subtract the mean of each feature so the data set is centered around the origin. This ensures that the PCA focuses on the variance in the data and not on absolute values. It is also crucial for calculating the covariance matrix, which is central to how PCA determines the new axis. The next step is scatter plots. Once we have generated and centered our data, we create scatter plots between all possible pairs of features. These plots visually show us the linear relationships between features. For example, how x3 changes with x1 or x2. If the features are strongly correlated, we will see them line up diagonally. This is the kind of redundancy PCA aims to remove by compressing the data into fewer dimensions. Then next is apply PCA. Now it's time to apply PCA using a Python. We import PCA from Sklearn.decomposition. Set the number of components to 4 and fit the model to our centered data. What this does is calculate the directions or axes in which the data varies the most, the principal components. Next is principal components. After fitting the model, we extract the principal components. These components are actually vectors that show how much each original feature contributes to new axis. For example, a component might say PC1 is equal to 0.7 into x1 plus 0.2 into x2 minus 0.6 into x3. These new axes are orthogonal and ordered by how much variance they capture. Next is PCA interpretation. PC1 captures the most variance. PC2 captures the next most and is perpendicular to PC1. We analyze which original features are most responsible for the variance in each component. This tells us what the dominant patterns in the data are. Next is advantages of PCA. It reduces dimensionality without losing much information. It transforms correlated features into independent components. It helps filter out noise. And it's a fantastic preprocessing tool before applying machine learning models. It makes your models faster and often more accurate. Next is conclusion. PCA is a powerful way to simplify data and reveal hidden patterns. It helps us understand how features relate and is widely used in fields like image processing, bioinformatics, and finance. Whether you are cleaning your data or preparing it for machine learning, PCA is a tool you will use again and again. Thank you.